Hello everybody and welcome to today's webinar. This is Thomas and I'm going to be your host for the next half an hour, 40 minutes, so I can present to you some of our solutions regarding Hollowcore and the production process behind it. Let's get right into it. As you can see here on the left of the screen, I have my information, and that's why I made the PowerPoint presentation. If you would like to discuss more after the webinar and have some questions privately, I'm very willing to answer them. So make sure you send me an email, give a call, and we discuss. About the webinar, as I said, half an hour, 35, maybe 40 minutes, depends on how fast the software will respond. I'm planning on doing a lot of things in a short amount of time. So yeah, enjoy, sit back and enjoy. I will just hop right in. If you have any questions during the webinar, make sure you send them. I unfortunately do not have any of my colleagues with me today, so I will answer the questions right after the webinar is finished. I'll take this down, hop right into the software. As you can see here, I have created a project, called it a webinar. This is where we're going to do our Hollowcores. For those of you who don't know already, when we want to activate the impact for CAD, either AutoCAD or BricsCAD, what we usually do is we create a floor plan right here, or an elevation drawing, depending on what we want to draw. If we want to draw walls, in this case, I draw a floor plan because I'm going to do Hollowcores. I have done that already. I think I have also opened it here. As you can see, some of you who've been more experienced users can recognize this is our beginners course project, and I'm just honestly gonna dig into it and show you how easy and fast it is to draw the floor and the Hollowcores. So what we have in Impact, we have this module here that basically draws Hollowcores extremely fast. Always top left corner, draw Hollowcore. We come into an abundance of information here. You can see that I have different sections. I can select my sections. I have predefined my sections. The sections can look differently according to your standards. You can predefine different strand patterns. You can have, you see here, this is the 4, the 5, the 6, the 7 is strand patterns underneath. If you have like 5, 2 is like 5 under, 2 up, and so on and so forth, right? In this case, I'll just use a strand pattern 7 just for the sake of this example. The same with the edge details. You can predefine some edge details. In this case, I will put some sloped ones. It does not really matter. I just want to show you also how it looks in the project manager when you have end caps and how the software adjusts to the different shapes at the edges. I will start straight away. You have possibilities of drawing Hollowcores with different ways, by creating a polyline, by selecting internal points, which I'm going to do now, or making your own points or windows. We'll try a little bit of everything so you can see the different possibilities. In this case, I will do internal point. As you can see, the internal points have been recognized and the internal cutouts have been recognized automatically from the software. We'll say continue. I will put the tolerance and the offset from the holes to 10 millimeters. And then I will put supporting length at 0 because I have actually already predefined that in my area. I have taken into account the support length. As you can see, I have to press a lot because the areas here are actually many during the support length. So here we are. This is not the way I want my Hollowcores to take. So I will press R, rotate, and then try to select, a spot here, so I can have the most optimal solution. So the cut slab can be, at another place. I'll press enter, and then I can manipulate the cut slab. I can say next, and then next, and then the cut slab is basically here at the end, and this is what I want to do. So I will say apply, and that's basically it. Now I have created slab here with a hole, automatically defined circular hole between those two slabs, already defined, and part of my floor is being done. For the other side, even though they are symmetrical, the holes and the cutouts are not the same. So for the other side, I will just do the exact same definitions, exact same strand pattern, and draw a window of polylines. I will take this and finish it here. Then here I have to define my support length, 80, 0, 80, 0. Of course, you can write whatever you want. I don't want any slopes. And at the same manner as before, I will say apply, and then I will go next, and I will keep my cut slab here. I will say apply, and I have made my slabs. In this case here, just to see something different and how we can manipulate fast the slabs, I can create a little hanger detail. Hangers in the software have been created as inserts, custom materials, you can call it, and then what you have to do is have predefined your hanger in the software, select the slab to support, select the two supporting slabs, and then draw your little open space there. Select your hanger detail that fits with the Hollowcore height that we have just created, and then it looks like that. It actually creates also some small recesses on the slabs on the near side of the main supported slab. So we did that, and if we want to make a simple cutout, for many of you who are using, we can throw a recess or a filling. You can do this element. I'll just do a cutout, rectangular, say OK, and then I will just take this here and just draw my rectangular. Press enter, and then it's created as a cutout. So for now, what you are seeing in my floor plan is you are seeing like some 2D things being created with some lines and polylines. However, if I move my view, you will actually see that the Hollowcores are being created in 3D. So there is also depth in them, and also height according to the values of our drawing and our elevation values for the slabs. So these are adjusted automatically. I will continue drawing, for example, this part here, and this part I'm going to separate it into two zones. I will try to make a window here and then leave the rest so we can manipulate a few things and see what we can do. So I will draw the Hollowcore. I will say same definition. Go say OK. Create my little window here. Right there. In this case, I want 80 up there. I want 0. And then here it doesn't really matter if I put 0 or 80. I will put 0, so I can show you that also. No slope, small like that. As you can see, my definition allows for a small little cutout. Of course, this is not acceptable. I will say apply, and then of course go in here and delete that little space there. You can always select the slabs and move them, or leave another space that you want to fill in with concrete, in situ, if that makes sense. If the dimensions do not fit the 1.2 increments for the slabs. Continuing now, I actually can see here that I can actually fill out my area with the slabs and make them bigger. So what I'm going to do is select those two, double click on them, and edit the length automatically. I can go to the properties, manipulate all the things that I have done, because a lot of people might have a question: how can we edit them? How can we do this fast? There are a lot of options that you can adjust length and make it bigger. In my case, I don't really know how much is that length here, so I will take the length, go from here, extend, select from here, and then hit here, exit, and now I have expanding the slabs. I will do the exact same thing here, a little bit faster this time with no more explanations in a sense, and then go from here to here. You know, the snapping, sometimes it's fine. Exit. The most important is to keep the line of where you want to go. They're not going to become, you know, slopes or something. And the last part is I want to draw this with a small Hollowcore. I can do it very quickly. Again, same way. I'll just draw the window here and go all the way down here. I'll put 80 up there, 0, 0 because this is predefined. None. Enter. And as you see, this slab is only 1.08. That's it. The cuttings, see, we have this nice little saw, if I'm saying it correctly in English, that shows that the saw wheel, that shows that this is a cut slab in a sense. In the same manner, I will just finish up and do also this last space here. Again, you can predefine the area with a polyline. I have not really done that, so I will put 80, 0, 80, 0, yes, sun there, next, 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 apply, and we are finished right here. There is one little cutout here. I forgot to do it. Let's not be very repetitive. Let's do it immediately. It is here. Draw recess, select the slab, cut out, okay. Do it here and there. So the one thing that I haven't done yet is, of course, fill out this area and this area. And I'm going to do that by just selecting my slabs, the ones that I have already. And for the sake of this example, of course, in real life, things are more complicated. It doesn't take also 5 minutes to draw Hollowcores for a whole floor. What I'm going to do is basically mirror the slabs with this great function here. Just mirror the slabs. I'll just find the center point of my model, which is this one, and then I will just bring them from the other side and make sure they look okay. Everything looks fine. So I have my slabs. Again, everything is in 3D, and most of the cutouts that I need were added or created automatically while I was drawing my floor plan. And we have a small model here in less than seven minutes or something. And that was the part that generally will take the most time in our webinar today. So what I'm going to do now, as you know, first step is to draw, edit, manipulate the dimensions. The second part is to save the Hollowcores in the database. If we do not save the Hollowcores in the database, then we cannot move forward in the process. Saving doesn't mean we are approving anything for production. I will just say save all, and then I will just wait for the software to recognize all the Hollowcores in the drawing and asking me what number I want to give them. I'll give them HOSI HC01, press enter. And of course, Hollowcores here that they have similar geometries, or they look exactly the same, we will get the same element mark, because I have defined that the element mark should remain the same when I have similar objects in my project. That's of course for simplicity and for not trying to adding a lot of element marks. So you can see here those 3 elements, they have a different ID, impact element ID, but or 4 in a row, they have the same element mark because they are the same. And same means they have the same shop drawing or the same drawing. For now, I'm not going to generate any shop drawings. The process is very simple. You select the Hollowcore, you generate the shop drawing, and you say okay, and the shop drawing is generated in a split second, 5 seconds, you can say. But in my case, I want to show you something a little bit later. One thing I haven't told you is that, of course, that for example, if for some reason you add lifters or you do things like adding core fillings and these type of things, we have great functionality here that you can very easily draw a core filling, so you can select your slab and then select how much you want the core filling to be. You don't have to be 100% precise now, but you can actually select the length here. So for example, I want the core filling to go to cores 1, 3, 5, 7. So I will just delete this one, delete this one, delete this one, and delete number 8. And then of course the length, of course, I will keep the same now, but you can always adjust the length. If it should be 780 instead of 781, right? You say okay, and you do that. If I use existing element mark, all the Hollowcores here will get the same core filling. So in my case, I will say no, and I will just use the next available, which is HC20. And the same with the lifters. Just as an explanation, a very quick explanation, I will select an object and see here, you select one of the custom materials for your lifters if you are using lifters, and of course you can predefine them in the definition. This is not something I have done on purpose, so I can show you how you can easily add lifters to your Hollowcores. If I say okay, the lifters have been added, I will say now yes, because I want the lifters to be added also to this and this and this element. And yeah, that's basically it. Drawing Hollowcores, we'll come back to it, but first let's go to the project manager and do some of the fun production stuff. So I will say reload model. When I reload model, I generate the elements from scratch, bringing in the new Hollowcores and the new materials that the Hollowcores were created from. In my model, you will be able to see that the Hollowcores actually look very detailed in full 3D view. As I said before, the cutout, the circular cutout at the edge looks pretty nice. The finishing on the side also pretty realistic and great. And again, you can see here the Hollowcores from the top and all the cuts that we made during our initial of course, our initial design. Now, the next part that I want to show you is, for example, I have made my ground, my base, and that's why I said this was the most difficult part. The second part is to create more of those. And in my case, because I can say I have elements that they are basically, floors that they are the same, I will just go and create the floor 2 from floor 1. So I have the possibility to copy the elements. The elements will keep the same element mark, and the situation will be extremely fast. Or I can say copy elements and element marks, and then decide a new element mark for the new floor. So if I do that, I can just go to floor 2 and then just go by, for example, 100, and also I can copy the shop drawings, say copy. So the new floor will get this, like from 01 to 101, right? And then the old drawing name will be 05 and the new will be 105. So, but they will have the same drawing. We say okay. Again, this is not a process that takes a lot of time. You see, the elements have been successful correctly. The model is being regenerated, and we have basically 2 floors of elements. And we will do the same one more time. Just copy elements and element marks, increase from floor 2 to floor 3. I don't care about copying the shop drawings. This is not really handles anything about the shop drawings. Say copy. Okay, something is wrong, so I have to go check the log and see marks and drawings. Okay, something about the elements. I have forgot to, of course, I have forgot to increase the value of this. I did that now. Copy, copied, and the Hollowcores have been created in the model. Very easy, very basic. A lot of you now, you will wonder, we do this and then we have the Hollowcores, but of course in real life the 3 floors of course are not going to be the same, so we might need to manipulate something, we might need to do something. So what can we do? How can we do that? Because now, you know, you didn't really give us anything, right? And I understand that. So in this case, you can, for example, write, you know, floor 3 or something, and then go to your floor 3, say okay, automatically create floor 3, okay, then open your floor 3 drawing. It will open automatically here in Impact. Your templates will be adjusted, and the only thing you have to do is generate the elements of building 1 floor 3 and say okay, and then you can basically select them. Here they are. Select them, go to your plan, edit them, and for example edit if you want the you can edit the height, and you can create another type of Hollowcore if that's what you want. In this case now that will take time to save and edit and resave, or you know, do cutouts and stuff, so I will just leave it for now, and then and then I hope you get the point in that sense. Let's go back to my model view. So what I want to do is set the erection sequence now. The erection sequence for me and the Hollowcores is actually pretty important. Why is it important? Because a lot of times the erection sequence can also, you know, shows you, you know, the way that you're going to stack your Hollowcores, because you want the erection sequence to be reversed. The first Hollowcore to be on top of the stack should be the one to be erected first on site. So setting the erection sequence for me makes a lot of sense here. What I'm going to do though is I'm going to create to just go to my erection planning and select the Hollowcores on the way that I want them to be erected. In that sense, I can do a lot of things here, but I can, for example, select this first, this after, and then I will take this and this as the extra ones, because I don't want the cut slabs to be, you know, I don't want them to be on top of my stack. Anyways, I will just do the same here. Take this also, and then I'll just do that. Continue with this, and then take the last 2 here. I will add the elements. The elements are getting now a new erection sequence, and I will say apply. And now we have to do the same thing for the 2 other floors. I will do it very quick now for the sake of the webinar, but again, as I usually say, it is best if you spend a little bit more time thinking about the erection sequence rather than not thinking about it and then having issues later. So think about how you want to stack your elements, think about how you want to produce your elements, and then make the erection sequence accordingly. So you can help the people on the actual transport side to do this very fast. I will say add elements, apply, and the same for floor 3. As I say a lot of times, the software is as clever as we are. Like, it doesn't do really magic, but it can recognize a lot of input that we are giving it, and we actually ourselves can use the software in a smart way. So now I have this building, and another cool function I really like to see it all the time and show it to people is actually, you know, I can go to building 1 and actually I can copy my whole building and create even more elements, even more Hollowcores, you know, for building 2. So I can copy building, I can say, like, you know, building 2, I can pick a point and basically I will just put it a little bit here. I will also rotate it by 90 degrees, copy the erection sequence, which I have already, and then I have already a new building for people who are actually creating elements, Hollowcores on Hollowcores on Hollowcores. You have already created a 3D beam model ready basically for production with a few adjustments, and you have already a lot of elements in your model. Yeah, so now we have building 2, building 1, and we can go further with our planning process. The planning process, the CAS planning, as I promised you, has a lot of information now. But what we have done is given us a good start. But there is also a few things, as I said, how I can use the software more efficiently. Before I do the CAS planning, I have to say here, like a lot of people want to do the transport planning first, or the stack planning, and then according to that, do the CAS planning. That's also fine. We can also do that. That's not a problem. For the sake of this example, I'll just go do the CAS planning first, just because I'm following the performance process rather than another process that a real factory has. So what I'm going to do here is basically select all or a part of my Hollowcores. But before I do that, I want to go to my element IDs, create my grid preset ready for CAS planning. So I have all the columns here, and I'm going to look into the strand patterns and the number of strands. So what I want in order to be efficient here is I want to take away all the cut slabs. And how can I do that very quickly? Of course, I can filter out from the widths, or I can actually, filter out from the number of strands. So I'll take all the ones that they have several strands, meaning that they are full size Hollowcores. When I do that, all the cut slabs have been marked out, and I will take this and I will just, according to my plan here, I will do something now. Maybe I should take a little bit less. Take this, select the 2 beds, and try to multicast for today. Now you can use the erection sequence here, or you can use width, the length, ascending or descending. Usually here for Hollowcores, I specifically use, descending, but of course every factory has its own properties. One thing that it is not really relevant here is that we have changed on the multicast the specific number of elements per cast unit. So if you have a table with specific elements per table, so you can define that. So we do not have only the single element cast unit anymore. Just a small parenthesis. I'll say start. Now the status, as you see, changes automatically, and we fill out the bed according to the different lengths. And of course, we could have done that according to the erection sequence. If now I go and filter out only the strands, the elements with the small things, I can just, I can go to my calendar view, find the next available date, and maybe take this one and say here, multicast, same thing, start. And you will see that if they actually fit, they will be also planned. They will fill out the space of your bed, because this is the realistic one to do. We'll fill out the space of the bed as much as possible. Then you can come and cut them in the way that they should be. This information can also be exported to plotters in Hollowcore machinery that predefine the space in your beds, in your lines, in your Hollowcore lines. The transfer planning. For the transfer planning, usually what I do in the same manner as I did it before, I do the stack first, and I do the stack first because there is a specific reason, because a lot of times I can have two stacks of Hollowcore on one transport. So I'm taking the full size ones, and I will just again select a small part of the project. I will auto stack them. I have created this one called HC horizontal. Erection sequence reversed, meaning first one on top, the first one to be erected, last one on top, first one to be erected. The load date is not really relevant for now. This is not a real project that we're going to deliver anyways, so we just use the dates the software proposes a week from today. Say OK. And we create the different stacks. So I have my stacks here, and you can see how the Hollowcores are being stacked in full 3D. And in some cases, like this case here, this doesn't look fantastic. So for example, maybe we can find a little bit more easier. This doesn't look fantastic. This looks great. But for example, this one, I want this one to go all the way to the top of the stack because it's the small one. So how can I do that? I'll just move it and move it up at all times. So it can just go up to the on the stack. You can either use this one, or you can use this button, and then it ends up on the top of your stack. So now when I have my stacks ready, I can actually select them and create an auto transport. That means that my trailer can take the Hollowcores, and actually you will see here the number like 1, 2, 3. So for 6 stacks, it created only 3 transports because the maximum mass of a stack was 15 tons, and then the maximum mass that my vehicle can take, which is right here, is 30 tons. In that case, you see here pretty much looks how it should be looking. Here you see this Hollowcore is out of my trailer, and that's why the stack is red. You can always manipulate your stacks by putting them next to each other. You can like move it here, and again move it here, and now you can move your Hollowcores next to each other, and that will also affect the center of gravity for your trailer, plus the axle pressure on the rear axle, and how the pin reacts to it. Yeah, again, we have done a lot of individual webinars for transport. What I want to show you here mostly about the production thing is not so much about planning or seeing things in the future, is about manipulating the things in our element IDs, manipulating the things in our visibility here, and actually doing things from the resource manager or the element ID tab, because that's you don't really need to see the Hollowcores in order to plan them. You need to have, of course, target dates, and you need to have information regarding their strand patterns and their lengths and so on and so forth. And of course, if you do this process first, the process of doing the stack and the transport, then during your CAS planning, you have the information about the stack, transport, and do the stacking or the production according to the stack numbers and the transport numbers that you see here as an extra list. This is part of the main webinar. It was just a very quick flow webinar on how to do Hollowcores. The last part I wanted to show you, and that's because at least from my side, I have seen a very bigger use of Hollowcore wall and Hollowcores being used as, you know, as boundary walls or external walls or buildings. And this is something we have developed for more than a year now, but we do not really advertise it so much, and I don't really know why. And that is the boundary wall and the external wall for Hollowcore. So what I want to show you here is how easy it is to actually draw that. So here is the main module for Hollowcore, and those 4 functions here are the main functions for your horizontal, basically, Hollowcore wall. I will take this one, I'll say draw wall, and you will come to a window where you have different definitions of Hollowcores stacked on top of each other. In this case here, we are allowing 3 definitions to be on top of each other, and we have that they are actually, you know, having kind of, if you see it as a battery, you have a pole here, you have like the negative and then the positive pole, right? And then you kind of create your boundary wall between those columns or whatever foundation columns that you can bring those Hollowcores in between. This is a cheap solution, and a lot of people are using it for creating boundary walls around, you know, farms or bigger buildings or even houses and so on and so forth. So if I press OK here, I can just start drawing my Hollowcores. I'll go from the middle, and I will just very quickly manipulate this. Again, I'm using only one hand, no need for more here. I'll just do it properly this time. I'll just finish off the whole side. I put only one side here, just so I can. So now you see I have unmarked Hollowcores, and if we see it in 3D, now we have a model of unmarked Hollowcores right here. They are just Hollowcores that they look like that. They are just stand out. But when it comes to production, of course, they will produce flat out on the beds. That doesn't change anything. It's only the visibility, and it's how easy you can actually create those if you are using this specific module. Another way of doing it is doing the vertical Hollowcore, and that's basically creating a line of Hollowcores that they are just like that. This is about external factory walls, external walls for buildings or countries with no real seismic problems. And we can just say here, you can see just a small little example how it looks. You go like that, and then it creates Hollowcores, and then you can just decide where to finish and where to stop. And if you want to have a cut Hollowcore or whatever, I'll stop here, and then you can add the ridge, and that will go from here to here, and then I will just move it so you can see that I can actually have a ridge of like 32.4, that is to 33 degrees. These are my Hollowcores. I will now save them again. I'll just do this save all. They will give given a new name. Just put 01 instead of 1. And then the software will decide which element will take what name. There is one question, I guess. There is one question, I guess, people will ask here, and that's you know, okay, now you show us in the flat ones how I can actually, you know, do the openings, do the core fillings and all these kind of things. How can I do that? My floor plan. In all reality, the best thing that you can actually do is generate the sub-drawing of this Hollowcore here. And as you see, it is extremely fast. You need the sub-drawing anyways for documentation purposes, even if it's just a normal slab. Open the sub-drawing. And then from the sub-drawing, and this is on purpose, I haven't said that before, the connectivity that we have between the sub-drawing and the floor plan is great. So what we can do is actually create our, you know, draw the recess or the filling here directly on this on the slab. So I can add this one, and then I can also go to my Hollowcore tab here, which I can actually draw some core fillings. I can take this and this. You see here also the functionality is great, because now the different the different cores have different sides. I will again delete this, maybe delete this, and delete all the even numbers, and yeah, just say okay. Now I have my core fillings, and at the end I can just in order to save, I will say material takeoff saving, and going back to my floor plan, I will just update this, and all the my opening or my okay. I don't know why the opening was not created, but let us do it one more time. Yeah, it's because I was a cutout rectangular. Okay. Let me see here. Maybe something is. Yep. Now it's created. So hopefully, when I press update here, we will see the opening. And going back to my model view, we will see how it looks also in the project manager. Promise 40 minutes, I can see is 41 minutes. We give it a little poke here waiting to be updated. And I promise you after that, I will take a look at your questions. The webinar is now concluded. If you have any questions, please write them down. I'll wait a couple of minutes, and yeah, and I will see here. Perfect. See here, that's how my Hollowcore looks. My Hollowcore external wall looks. That's how my actual Hollowcore boundary wall looks from this side. Now some of you are using these functions, so yeah. Any more questions? I cannot really say something here. Great. Thank you so much for your time. There are no questions. I appreciate all of you coming and taking some time from your busy days to see the webinar. Next webinar is a webinar with my colleague Desis. He's going to do a Revit webinar at the end of October, and of course I hope most of you can come to the user conference in early November, where we can meet each other and have some nice talks and discuss more about impact and your projects and all the great things that you are doing. Thank you so much. Have a great day, all of you. Bye bye.